Today we are going to talk about what the body does to drugs after you take them. Drugs after to get to the brain. What's the only way they can make somebody feel different? And is it the only way to get high? For drugs to get into the brain, they have to be in the blood. What various factors determine how much drug gets into the blood and the brain? And how long they remain there. Overall, what happens to drugs into the body is referred to as drug dynamics. The first thing that happens after you take a drug orally is that it has to be absorbed from the stomach and the intestines into the blood. From the blood, it passes into the brain, and again, all of these drugs have to get into the brain to have an effect. A large fraction of the blood pumped from the heart goes directly to the brain. Drugs that are injected directly into the bloodstream are not absorbed by the stomach but are still passed into the brain. Some drugs such as nicotine or inhalants are absorbed directly from the air in the lungs to the blood. Different drugs have different absorption efficiencies. Some drugs are nearly all absorbed and others are not. The next step is that drugs are metabolized or changed. The metabolism or chemical modification of their drugs can result in the cessation of their action. And metabolism can also enhance the next step, which is excretion. Drug metabolism usually takes place in the liver, but it can take place in other bodily organs as well. It's the enzymes in the liver and where they modify structures of drugs. An example is the metabolism of ethanol. Ethanol or alcohol is acted upon by an enzyme called ethanol dehydrogenase and other enzymes to form acetaldehyde, which is the changed further or into acetate. Acetate is not an active substance, so a metabolite or ethanol is inactive, and the effect of taking ethanol or alcohol is terminated by its metabolism. This next example shows the many possible metabolites of nicotine. You can see that it's extraordinarily complicated, and many different kinds of metabolites and chemical structures are possible. Of course, you don't have to remember all of this. I show you this just to give you an appreciation of how complicated drug metabolism can be. In the next and final step in a drug's journey in the body is drug elimination. Drugs and their metabolites are removed from the body, mainly in the urine or feces. A couple of important concepts relate to drug elimination includes clearance, which is a measure of the body's efficiency in eliminating the drug. And the second is elimination half-life. The half-life of a drug is a measure of the rate of removal of the drug. It's the time needed to remove or metabolize 50% 97% or half of the drug. So we have discussed three main steps: drug absorption, drug metabolism, and drug elimination. The graph details with the idea of half-life. I show the disappearance of two different substances A and B from the blood, and they have different half-lives. Drug A has a shorter half-life, and drug B has a half-life twice than of A. When we look at the levels of these drugs in the blood, which are the solid lines, you can see that one of the curves falls at the zero much faster than the other, and that means that drug A have a shorter half-life. If the half-life is shortened, then the drug disappears faster. Normally, for 97% of a drug to be eliminated from the body, it will take 5 half-lives. But if a drug taken orally, then the drug has to be absorbed fast. It builds up slowly in the blood, which the dotted lines in this image. After it builds up to its peak, it is then eliminated at a rate according to its half-life. It's worthwhile pointing out that not all drugs are metabolized in this fashion. Ethanol, for example, is metabolized at a steady rate rather than all fractional rate. Now I'll introduce the topic for next time. One of the practical impacts of a drug being excreted into the urine is that many drug screens and tests have been developed to screen for the presence of drugs in the urine. It's interesting that sometimes the metabolized of a drug persist in the urine for longer periods than the drug itself. Therefore, in some cases, the targets of the tests can be the metabolites of the drugs.